Hello, everyone. Good evening from Washington, D.C., and good morning to all of our colleagues from Azerbaijan. For those of you who may be joining us for the first time, my name is Elizabeth Goffey, and I am a project manager with the U.S. Department of the Interior's International Technical Assistance Program. Under the U.S. Global Water Strategy, my office works with our colleagues at the U.S. Department of State and our embassies and consulates overseas to deliver short-term technical assistance on water to our foreign government partners around the world. Over many months, we have worked with the U.S. Embassy in Baku, our esteemed colleagues at the Ministry of Ecology and Natural Resources in Azerbaijan, and our team of U.S. experts to design a program that will address the growing need for sustainable water resource planning in Azerbaijan. As you may recall, our previous presentations focused on methods of measuring and analyzing future water availability. Today, we will take that discussion a step further by highlighting specific water conservation approaches employed by the U.S. Department of Agriculture's Natural Resources Conservation Service. As this is the fourth and final planned presentation in this series, I would like to offer my State Department counterpart, Foreign Affairs Officer and Project Manager, Tess Erickson, the opportunity to say a few words. Tess?
Thanks, Elizabeth. Good morning, everyone. My name is Tess Erickson, and as Elizabeth just said, I am the project manager for AWEP with the Office of Conservation and Water at the U.S. Department of State. With implementation support from our U.S. Department of the Interior colleagues, my team oversees the Ambassador's Water Experts Program, or AWEP. First of all, I'd like to thank Dr. Strobel for his excellent presentation that we're about to enjoy, as well as my colleagues at U.S. Embassy Baku and everyone else who has had a piece of this program for their support as we put everything together. The U.S. is committed to sustainable water resource management, and we're so pleased with how this program has come together. We hope that it has been helpful to you. This may be the final session planned for this program, but as Blake and Elizabeth have said before we began, it does not have to be the end of our time together. We hope to continue to work with the embassy to develop further programming and to continue discussing these important topics. Thank you to all of the participants for your time and attention. We look forward to our future collaboration. Thank you so much for paying attention to me. And with that, I'll turn it back to Elizabeth so we can get started with our program. Thank you.
Thanks so much, Tess. Again, we are really so excited to have everyone here with us today and are looking forward to a very interesting presentation from Dr. Strobel. A few quick reminders about today's session. First, this session is being offered in both English and Azerbaijani. As I mentioned before, to select your preferred language, please click on the round globe icon in the Zoom menu at the bottom of the screen. Second, today's presentation is being recorded and will be available for download and distribution on our YouTube channel following this session. To preserve the audio and video quality, we kindly request that participants stay on mute and keep their cameras off unless they are presenting or asking a question. If you do have a question, please feel free to use either the raise hand feature, type your question in the chat box, or save it for the dedicated time for questions at the end of the presentation. With that, I think we are ready to hand it off to today's returning speaker, Dr. Michael Strobel, Senior Natural Resources Specialist for Hydrology and Climate Science at the U.S. Department of Agriculture's Natural Resources Conservation Service. Mike, please take it away.
Thank you, Elizabeth. I'll turn my camera on just for a little bit here. As mentioned, I'm working with the Natural Resources Conservation Service and have recently taken on a new position. Previously, most of my 34 years in government has been as a hydrologist. And currently, again, I have a kind of a new title as a Senior Natural Resource Specialist because I'm working with the Office of Climate Change now. So a little bit different direction, but still dealing with water resources and water issues. And I want to start it too with a little bit of an apology. We're in the middle of a snowstorm here where I live, a very heavy snowstorm. And so if I have any kind of connection issues, if I get disconnected, please bear with me. I will try to get back on as quickly as I can, but I don't anticipate a problem, but I'm just giving you a heads up ahead of time here. So I'll turn off the video and I will go ahead and share my screen, and we'll start with that. Okay, and again, just this what I will talk about today is some of the conservation programs that relate to water that are part of the Department of Agriculture's Natural Resource Conservation Service. And in our previous 3 presentations that we have given as part of the series, we discussed the Department of Interior's Water Smart program. We discussed the Department of Agriculture's Snow Survey and Water Supply Forecasting program. And then also we discussed NOAA's River Forecasting Centers and Water Supply Modeling. So today I'm going to kind of take a different direction outside of those types of programs and talk more of a generality of what the agency I work with, Natural Resources Conservation Service, and I will refer to this as NRCS throughout the presentation, just as an abbreviation. Some of the programs that we offer as technical assistance to farmers, ranchers, foresters within the US, but also are available for international assistance to help others with really assisting in the agricultural productivity of their own operations, private landowners. But first I want to give a little bit of a background of the agency itself. So the agency has been around since the 1930s. And really what the purpose of this agency is, and it's really kind of an interesting part, is that we're here to assist private landowners. We're a completely voluntary approach to helping improve soil health, agricultural production, local economies, and really there to assist those that work in agriculture. At the same time, also improving our nation's quality of air, water, soil, and habitat. So again, this is nice because it is voluntary. We work individually with folks. We're not regulatory. We don't enforce any kind of rules or regulations. We're there to offer assistance to help individuals. We really have 2 parts within our agency on how we do assist folks. One is what we call financial assistance. And so here we help private landowners who farm, ranch, or forest to apply conservation practices on the land. So we provide funding to help them improve their operations. The other side is the technical assistance. And here we provide expertise in helping land management to conserve and improve soil health, how the land is managed, help them reduce costs, help them increase productivity. So we provide expertise in areas such as soil science and hydrology, and other parts of natural resources to assist individuals. Our agency began in the 1930s. It's kind of an interesting story because in the 1930s in the United States, there was a prolonged drought, a dry period that really had 2 issues. One was the drought itself, but the other was how people farmed and managed the land. Oftentimes their practices were insufficient for protecting soil health. And so there was much erosion, much stripping away of topsoil that really impacted the central part of our country. When our first director was talking to Congress about establishing an agency to assist with soil conservation, it was interesting because at that same time, there was a dust storm that hit Washington, D.C. that came out of the Midwest, and the skies were orange with soil and dirt in the air. And the timing was actually very good because they got approval then to establish our agency, which was originally called the Soil Conservation Service in 1935. we later in the 1990s changed the name to Natural Resources Conservation Service, or NRCS, because it kind of overviews a broader mission, of more than just soils. We're looking at all the natural resources in this area. As I mentioned, much of the cause of this Dust Bowl was extended drought, but also really poor management of the land. There was times where they would not leave cover crops on the land. There was times where they would do repetitive farming, and so they actually ended up damaging much of the soils, much of the topsoils in the central part of the country. And it took many, many years for this to recover through some of the processes that our agency assisted with. The key part of this is that NRCS is totally voluntary. We are not regulatory, as I mentioned, and we don't enforce any kind of laws or policies. We work with private landowners, with individuals, to help them improve their operations and to help them improve the land. We have offices in about every county of the United States. So we have offices located throughout the country where we work one-on-one with individual farmers, ranchers, foresters, to assist them and provide, both financial and technical assistance to help them with their operations. So we have a very widespread and diverse workforce here that isn't just, like I say, it doesn't just work on a broader scale with other agencies, but also works mainly one-on-one with those landowners. So what I want to do is provide some overview of two of the technical centers that NRCS has that focus on water and provide information and guidance to producers and soil and water conservation districts and other local, state, and federal agencies. That also is information that others can tap into through the internet and get information and work with individuals on specific problems. The first one is the National Water Management Center. And this center really has kind of a broad team of experts that work with state and national specialists to look for solutions to water problems at a local level. So some of the areas they focus on are watershed operations, watershed rehabilitation, and of course, economics. And they have experts that provide webinars and training similar to what we've been doing with this program to help individuals, again, try to focus potential resources to assist them in their operations and with their water management. And some of the expertise includes water quality and water quantity individuals and hydrology and hydraulics. The other center is the National Water and Climate Center. And I talked about this in a previous session when I talked about the snow survey program, because that is a major part of what the National Water and Climate Center does. So I won't really go into much more detail on that snow survey side of it, because there was a whole presentation on that. But I will talk about a program that the National Water and Climate Center operates, and that's called we call it SCAN. It's the Soil Climate Analysis Network. And this is a network that looks at soil moisture and soil temperature across the country and provides information on that. So I'll talk a little bit more now about the SCAN program itself. And again, I'll use that acronym SCAN for the Soil Climate Analysis Network. The SCAN network is 222 sites across the United States and includes Alaska, Hawaii, and the Virgin Islands, Puerto Rico, so some of the territories as well. These sites, again, are really provide critical information. Now, as pointed out by Don Anderson in the last presentation, soil moisture is a critical component for water supply forecasting. So having this information helps with water supply forecasting, within the different basins across the country. And SCAN also provides a tool for improved agricultural practices, such as quantifying when and how much water to irrigate. So in many operations, a lot of the farmers just will irrigate on a regular basis, not when the crops need it, but they do it on a time basis. So just regularly irrigate. And having information on the soil moisture can greatly increase the operations and when and how much to irrigate. So you're doing it in an area that's been quantified, so you know how much water to apply. And in many situations, this has greatly reduced the amount of water used for irrigation. So it reduces the quantity of the water, but also reduces the amount of energy needed to pump the water for irrigation. And in some situations, it has decreased the amount of water needed up to 50% based on using this network, this information local to your area to assist in those operations. The other part of this is that we have soil temperature, so that along with the soil moisture. So that really helps in understanding when and how much to apply with ag chemicals, herbicides, and pesticides. It helps to understand when to plant based on the soil moisture and the soil temperature. So when are the optimal conditions for planting? And when are the optimal conditions on when to harvest? When can you get into the fields? And when is the situation best for that? So it provides a lot of climatic information that helps farmers in what we would call precision agriculture. They're actually not basing it on just how they've always done it. They're basing it on science, and that is a key piece. In addition to the 222 SCAN sites across the country, the SNOTEL network, which I talked about in a previous presentation, many of those stations also have soil moisture and soil temperature. So we have an additional over 550 SNOTEL sites in the Western US with soil moisture and soil temperature. So we have together a very large network of information that's available. A SCAN station is very similar to a SNOTEL station. You can see the picture on the left side here, upper left, that shows what a SCAN station looks like. It is a station that collects a variety of climatic information, such as precipitation, air temperature, relative humidity, solar radiation, wind speed and direction, and barometric pressure, all above ground measurements that are used to establish the climatic conditions at a location for various times during the year. This information is collected continuously, transmitted every hour, so it's available in real time on the internet. And similar to the SNOTEL network, as you see the map on the upper right, you can go in and click on any site. And if you do that, you'll bring up a table with metadata about the site. You can bring up graphs and charts that show the conditions and the trends at the site, and other information that would be useful, again, for agricultural operations. At each of these sites, we also have soil moisture and soil temperature. The sensors, and I'll talk a little bit more about the sensors here in a minute, are at depths of 5, 10, 20, 50, and 100 centimeters. So we have 5 different depths at each site. And then this gives us information not only just for the site itself, but also a vertical view at the site of what is happening with soil moisture and how that varies with oftentimes events happening on the surface, precipitation events, freezing and thawing of soils on the surface, etc. So it's a lot of good information, again, that's useful for agriculture. So for these stations, and just to give you a little bit of background on them, how we set this up, what are some of our criteria for where to put a SCAN station? And again, the purpose of the scan station is to assist those who do agricultural operations, the farmers and the ranchers and the foresters, with information so that they can base their decisions on science. We try to, let me get a sip of water here real quick. We locate each of our sites near agricultural lands, but we want to locate them on either federal, state, county, or university property. And the reason for this is that we want to be able to have that site established for a long period of time. Oftentimes private lands, if you locate a site on private lands, they change ownership and the next owner might not want that station on their land. It is critical for us to establish a long-term record so that we can compare what we're seeing to what we call the normals. So what we have a 30-year period that we can compare it to. And so that's why it's really important to put them on lands that we know will be within the same ownership over a long period of time, over decades, because that's what it takes to really establish a good site. We want all of our stations located in areas that are not irrigated. In other words, we don't want the human impact on the soil moisture, on the water conditions. So we locate these in areas that aren't currently being irrigated, so that what we are measuring is not something that has been altered, but something that is the natural conditions for that site. When we look at sites, we try to identify areas that what we call benchmark, or what are the major soil types across the country. So we want sites, scan sites across the country that represent all the different major soil types in the US. So we look at that as a criteria when we are installing a new scan site. And similarly, we want to have all the major land resource areas, which really represent the different climatic regions of the country. We want to make sure that those are also represented. So we'll look at that as a criteria so that we have representation across the country of different climatic regions. And so we're not just clustered in one area or another, but that we actually are seeing a larger snapshot, a larger picture of the country. The station needs to be in agricultural areas. Obviously, we're with the U.S. Department of Agriculture. We're looking at how our information can impact agricultural operations. And so we look at areas that are pasture, range, timber, cropped lands first, that then this would be a tool for those operations. And one of the things we also look at is a suitable location for station security. And security can be things such as concerns with vandalism. I mean, these stations have solar panels, they have other equipment, batteries and other radios, other equipment that potentially could be damaged through theft, vandalism, could be damaged through just somebody destroying the site, shooting a hunting rifle at the site, but also could be destroyed or damaged through natural conditions such as forest fires, grass fires, flooding. So those are the types of things we look at to make sure that we have station security, because the sites themselves contain a lot of equipment that we want to make sure is not altered or damaged. And we also are looking at trying to install the sites areas that are susceptible to drought, because this is a useful tool in assessing drought. Having the soil moisture is a good tool for our drought monitor, for our other agencies that use the information to identifying and establishing which areas are undergoing or are susceptible to drought. So we'll talk a little bit now about the sites themselves. So at each of the sites, we do measure soil moisture and soil temperature using a capacitance type sensor. And so you can see a picture of the sensor here. It's a 3-probe sensor that we use at different depths. And so what it does is provides information then on the soil moisture and soil temperature at those depths. And I'll talk a little bit about how we collect that information, how we cite these different sensors in the next slides. But we collect this information, it's transmitted then from each of the stations, as I mentioned, via radio or satellite to our major office back in Portland, where we then take the information, analyze the data, and provide it to those users on the internet, typically in what we call near real time. And why I say near real time is that it's transmitted every hour. So it's not instantaneous, but every hour we have information from these sites that we will then post and keep people current on what the data is doing. So one of the first things we do at each of these sites, and this is a really critical piece of this, is that what we do at each of the sites that are part of our network is we first establish a soil description to a 1 meter depth. So we'll dig a pit, and a soil scientist will get in there and will analyze the site, looking for the different soil types, looking for the different horizons, soil horizons, and looking for things like macropores, fractures, root zones, areas that would potentially impact the movement of water, the movement of soil moisture through the profile. So it's really good to have an established description of the soil types at each of these sites, because you have to understand the medium that of the soils. You have to understand the medium that's being measured in order to quantify the different aspects, such as the volumetric water content at a site. So having this profile is an important piece of it. Not everybody that has soil moisture sensors does this. I know our agency does, because again, our roots are in the Soil Conservation Service. We have, we really feel that understanding the soils as well as just the water content is a critical part of the network itself. So after we do that pit, then nearby to the pit, close by but not at the pit itself, we'll do two different holes. One hole will be a very small diameter hole that goes down to 1 meter. And in that hole, then we will place the deepest sensor. So it's installed vertically at 1 meter depth to get the 1 meter soil moisture and soil temperature. And after we install this, we'll seal the hole up so that there's no moisture transfer down the hole itself. And we keep it small for that same reason. Now the other sensors, though, we will auger in a larger hole, and these sensors will be placed horizontally. We try to make sure that we are very careful not to disturb the soils. You want the natural conditions. So we will install the sensors, disperse them around the small hole to minimize any interference, and certainly not to compact the soil. Even pushing the sensor in can slightly compact the soil itself. So we take every effort we can to not alter the natural conditions at a site. And again, these are then put in at 5, 10, 20, and 50 centimeters depth, so that we have that profile down that same depth. And again, it's nearby the pit that we measured. You don't want to be too far away, because soil types can change over short distances. So we want to make sure that we're measuring the same horizons, the same profile that we saw in the pit that we dug and sampled or measured. One of the things too when we step back on the soil probes themselves, is one of the things we also do, let me go back a slide here. One of the things we also do on these is, as you can see, the cables themselves are buried too, but what we'll do is we'll put a droop in the cables after they come out of the sensor and before they go into the trench, the buried trench going back to our station. is that we'll put in a small weighted droop line on each of these, because you don't want moisture following the cable down the into the sensor and altering the soil moisture at that sensor itself. So we again take great care to make sure that we aren't altering the natural conditions or the natural soil moisture at the site. And so again, having a kind of a depression, a drop in the cables themselves will keep water from transporting down the cable itself to the sensor. So our network is part of many different networks that are within the US. And you can see that many of these, from the map here on the right, you can see that there's a number of different states that have really gone heavily into looking at soil moisture. For example, Oklahoma, which is the yellow sites, they have soil moisture sensors in every county. So their network is very extensive. And other states have more or less, stations. Some have only a few. The SCAN and SNOTEL networks are the largest of the soil moisture networks in the US, but many of the states and many of the other federal agencies also have soil moisture. So we determined that it's best to share information. So we are establishing a national coordinated soil moisture monitoring network, which is a collaboration of various different groups, state and federal agencies, soil moisture scientists from universities, and others that work together then to share the information that each of these networks collect, and then give us a broader and more detailed view of soil moisture across the country. And this is a current effort that we have ongoing. It's being established. It's not in place yet, but it's something that we're working on currently. And along those lines, there's also the International Soil Moisture Network, which is a cooperation of different countries to share in situ soil moisture information. And this is a combined effort of the Global Energy and Water Exchanges Project and Committee on Earth Observation Satellites, Global Climate Observing System, and many other groups. So this is currently it's run out of Germany, but this is something that different countries that have soil moisture information, that have in situ networks such as ours, share information to. And again, it provides not just a national perspective, but an international perspective, a global perspective of soil moisture. And this is something Azerbaijan and other countries can certainly be part of with networks that they either maintain or establish within their countries. So switching gears here a little bit, I'm going to talk now just briefly about some of the different conservation practices within my agency, within NRCS. And this is information that, again, is on the internet and available to whoever globally would like to access it. But typically, this is what we do within our agency when we work one-on-one with private landowners. We have established 165 different conservation practice standards. And these are approaches that, depending on the situation, you go to a farm or to a ranch, and depending on what their current situation is, what their current needs are, what their issues and problems might be, we have different standards, different practices that we can offer to help alleviate and to help remediate some of the problems, some of the issues they might be needing to address. And as it relates to this talk, over 88 of these practices are related to water resources. And so I want to talk a little bit about some of these practices. One of the things that my agency does is we follow a 9-step process. which is really a scientific approach to conservation planning. You, instead of just going out and visiting a farm and seeing that they have, let's say, a stream erosion issue, you really follow a whole process here to make sure that we're doing this in a scientific and defendable method to make sure that the issue is addressed adequately. So this is, as you can see from the different steps, one is to identify the problems and opportunities. The second is to determine what are the objectives. So what does the customer need to both address the problem and improve the situation? We look at what the inventory resources. We try to look at what the natural resources are there, as well as some of the economics and other factors that might impact which practice we offer. We look at the resource data to see, the information for the site. We look at alternatives. What can we offer that can help improve the situation at the site? And then we evaluate these alternatives, which would be the most effective way to address the issue. And then the last three is when this actually moves into how we apply this. The first is we make a decision on which practice to implement. We implement that decision, and then we evaluate the plan. We'll come back and see how it worked out. And I highlight these last three steps because these are important about making decisions. This is when the landowner will choose which project or plan that would be best for the current conditions at their site. Then our folks, our planner from NRCS would then look at some, put together some documentation and send this to review with others to make sure that this approach is the best approach. And then once that's approved, then we provide that technical assistance and often financial assistance to help with the installation of some of these conservation practices. We bring in engineers and others to help make designs if that's needed for depending on the practice. And we also assist in other ways of, things such as obtaining the materials they need to apply the practice, obtaining permits. There's always various regulations that require permits to alter your land. We look at land rights, we do surveys, and we do inspections of any kind of the structures that are being installed. And then the last part is to, again, this is the important piece in my mind, is that we evaluate the plan. We implement it, and then we go back to make sure that it's working adequately. So we don't just walk away. We evaluate the effectiveness of this. We try to quantify how effective the plan was. How much did it reduce stream erosion? How much did it improve water quality? How much did it decrease the use of water for irrigation? How did it improve the land? So there's various things that we try to quantify as part of the conservation plan. And to also look at then to see, after we evaluate this, to see if we want to continue along the same plan that we're presently on, or if there's other things, other alternatives, other directions that we might want to move towards as we look at how the plan itself is how the results are and how well it's working. Now, this is a very busy slide, and you don't need to evaluate all this. Why I'm showing you this is these are the ones, the different practices, established practices that relate to water that I have identified, and there's 88 roughly that relate to water. Everything from riparian forest buffers to sprinkler systems to channels and vegetation barriers and wetlands. What I will do then, and I don't want to spend a lot of time on this slide, but I will talk about some of those, some examples of different practices that relate to water, and I'll give, in this situation, I'll look at 12 different practices and kind of give you just a highlight of some examples of some of these practices and how we assist landowners, agricultural operators in dealing with some of the situations and improving the land that they manage. So the first one I'll talk about is wetlands. And of course, wetlands are areas that are marshy with wet soils, typically what we call hydrous plants that live in the water. There's different kinds of wetlands, and some of them are areas that have standing water year round, and some are only wet part of the year. But what we can do with the wetlands is to actually, and thinking of wetlands is that we can either create new wetlands, we can enhance existing wetlands, or we can restore wetlands that had potentially been drained, farmed, and the landowner wishes to bring back where the wetland had existed before. Why this is important is that it really does provide habitat for a variety of biota, pollinators such as bees and other insects that are certainly assist in agriculture. It provides habitat for fish and wildlife. It can improve water quality because it filters the sediments and the chemicals of the water that infiltrates, and can reduce soil erosion and flooding by retaining water in these wetlands. And in doing so, it can actually recharge then the water supplies, the groundwater supplies. So there's a lot of different reasons for establishing wetlands on your agricultural land. Second one is terraces. These are man-made earthen embankments that are constructed along a slope in a field. Typically, they follow the contour, they follow the hillside, as you can see in the picture there. So there's two types. There's storage terraces and gradient terraces. The purpose of a storage terrace is to actually stop the water from overland flow. So it collects water and stores it so it can infiltrate into the ground instead of just running off over the land surface. And so these are used, and of course, these have been used throughout history. The terraces, you see areas in the mountain areas of China, Peru, and other places that have numerous terraces that how they manage to grow crops on areas of a steep slope. And terraces is one way of doing that. But another, like I say, another purpose of the terraces is actually for the water retaining itself. It's the idea that you're holding back water and letting it infiltrate, which is an important aspect then for the hydrology of a site. And then there's gradient terraces, which are designed to actually channel to slow down the runoff of water and carry it to a stable outlet, somewhere that's been constructed so that you're reducing the erosion by either the overland flow or by channeling where the flow occurs. You can retain the runoff for soil moisture. And of course, this does provide nesting habitat. A third one is conservation cover, which is a permanent vegetation cover. You can use either native grasses or other types of vegetation. And really, this helps a lot for a number of reasons. It provides nesting cover for vegetation or for wildlife and for pollinators. It reduces the soil erosion by just leaving this land in a natural condition, by planting natural grasses and leaving it dormant. Reduces the soil erosion, improves water quality, air quality. You have a lot of plant diversity. And then as for the soil health itself, it really increases the organic matter and improves soil health. And so it's got a lot of different purposes. It seems counterproductive for a lot of farmers to not be farming all their land, to not be producing on all their land. But there are really valid and strong reasons to have areas that have just vegetation cover that we leave alone, that we leave natural. And you can see that some of these reasons are listed here. And I think that frame of mind, that aspect is really starting to become more established with the farmers and ranchers that we work with. Contour farming is farming in rows, usually not up and down a hill, but along the sides of hills, slopes, slight slopes. So what this does is actually creates, it's kind of very similar to the terraces. This creates really hundreds of small dams because you're tilling, you're contouring along the length of the slope and not up and down the slope. So it can reduce the soil erosion because, so again, the water has a chance to infiltrate. It reduces sediment runoff, so thereby increasing, the water quality, the amount of water that infiltrates. So there's a number of reasons to do this. And so it's just a type of farming that we work with farmers on doing this. So they don't just go out and farm in straight rows, but they actually use the topography on their land itself in establishing and designing how they wish to farm for their row crops. Cover crops are things such as rye, oats, winter wheat that are planted to, as you can see in the picture here, we have corn that has been harvested, but then there's cover crops in between the rows of corn. And what this does is it really decreases the amount of wind and water erosion that occurs in the fields. Oftentimes farmers, and I've seen this here where I live in the northern plains of the United States, where a lot of farmers, because of just their previous practices, their attitude is they have an amount of pride where they want the fields to look nice, to look beautiful at the end of harvest. And so they plow under all the leftover vegetation and leave open fields. Well, this is really susceptible during the winter to wind erosion, to loss of soil, topsoil, and certainly a decrease in soil moisture. So we've been working with farmers to put ground cover, to establish ground cover over the winter so that it improves the soil health by adding this organic matter and increasing the biological activities. And if you actually plant as cover crops certain types of crops such as radishes, you can actually, the taproot can help improve some of the water infiltration. It reduces the weed competition, so you can actually use less herbicides because the cover crop is actually reducing the amount of weeds that can come into an area. And of course, it does provide livestock grazing. So oftentimes during the winter and spring, farmers and ranchers will allow their cattle, their sheep, to graze on these lands. And so it provides food for them as well. A pond is just, again, it's pretty self-explanatory. A pond is a pool of water that can either be built by damming off water that's running off, possibly a stream, which is an embankment pond, somewhere where the water would be naturally flowing out. And then there's excavation ponds, which is just a pond that's dug down to the water table as a pit. Having ponds on your land provides a number of opportunities. First of all, it prevents the establishment of gullies, so you're reducing soil erosion. And it can also improve and protect water quality by storing runoff water. If you have livestock, this provides water for the livestock, for fish and wildlife, deer and other wildlife in the area. And it certainly just the aesthetics, it helps the value and the beauty of the farm itself. Nutrient management is what we would call how we manage the fertilizers, what we put on our soils as nutrients and soil amendments. So by managing what and how much we put on our soils can really reduce the potential for nutrients to go unused. Farmers, again, just kind of like I was talking about with irrigation, and sometimes farmers just naturally irrigate on a regular basis, regardless of what the conditions might be. The same could be said for nutrients. And oftentimes farmers will just apply the same amount each year, in fact, through the season, as they always have, without really looking at what is needed for the soils. So we can look at nutrient management and really try to identify what's being applied and how much is being applied. And in doing this, we can reduce the potential for these to go unused and to wash into the water supplies. So it can improve the crop production by actually using the right amount of nutrients. And if you're not out in the fields applying these, it can reduce your cost, your energy costs for applying the nutrients to the soils. It certainly protects the water quality from not letting folks put too much nutrients on their soils, whether they're commercial fertilizers or animal manure. And then again, it utilizes it for, it really improves the soil health and utilizes organic byproducts that they might already have. So it's a good use of those resources, at the same time improving the conditions on their farms themselves. But it really has a lot to do with the water itself, the water quality, reducing what's there to improve both the surface water and groundwater quality from not over utilizing nutrients. There's what we call no-till or strip till. And so what this is even though you still have till crops or row crops, what you do then at the time of harvest is you then leave in the residue from the previous crop in the field. In this case, it looks like corn. And you just till just the rows themselves. So in between the rows, there is a lot of residue that's there. And leaving the residue there has a lot of benefits. First of all, it prevents the soil erosion. It improves and protects water quality. And it adds this organic material to the soils themselves. So it works that way. It decreases the amount of herbicides needed because it makes it harder for weeds to compete, to get into the soils and to grow. It adds carbon. So it's both the carbon sink, it stores carbon, which is great for our approach on climate change right now and trying to mitigate the amount of CO2 in the atmosphere, but also helps store that same carbon in the soils as well as the residue itself. But it has a lot of different aspects, as I mentioned, on the water side of it, of retaining soil moisture. You have this cover, you don't have so much of the evaporation of the soil moisture as you would from a bare soil. So it both holds moisture and retains the moisture in the land. So you can reduce the amount of irrigation needed just by having this no-till and strip till. Filter strips are it's just vegetation, and it can be grass, trees, or shrubs along the edge of fields. So you leave these vegetation strips along the edges of fields that really filters the runoff from the fields and removes the contamination before it gets to water bodies. And so, things such as lakes, ponds, wells. It's really nice because it can slow down the water flow and allow those contaminants then to be retained and not get into the water supply. But it also provides grass, trees, and shrubs, which helps the pollinators and birds and other animals in the area. It improves the water quality for fish and can reduce the soil erosion. So there's a lot of benefits with the filter strips. And a grade stabilization is something built along the edge of a field. It's an embankment, an earthen embankment built along a water course where there is a drop off from the field to the water. And oftentimes we have banks such as along the streams, rivers, and lakes that there's a water supply there, and there's a lot of the runoff then that comes off of the higher grade fields will drop over the embankment into these water supplies. And especially this happens during flooding, during major storm flows, where this drop in elevation can really cause a lot of erosion. So we can build and construct these earthen embankments, spillways, to be used as outlets to really kind of prevent the gully erosion that occurs. Working with other areas like the grass waterways and other areas where we have control can improve the water quality. And if it planned right, it can actually be a way of storing water. So it can help, again, with not just the water quality, but with the habitat that's at each of the sites. a grassed waterway is interesting because there's a lot of areas that are low points along a field where water runs off during events and gathers in a low area that oftentimes will be an area that does convey water, but oftentimes holds water in such that it becomes just a very difficult area to cross over because it's muddy. It causes a lot of stream erosion, can really impact water quality because of that erosion. And so we can install grassed waterways along these low areas. And what this does then is it actually protects the waterway itself. It's just planted grass that protects the waterway from erosion. And it does trap the sediments in this runoff water. As again, just like with other things, it provides vegetation. So the vegetation itself can filter the water, the chemicals, but also provides habitat for birds, animals, pollinators. And then the last one I'll mention here is a constructed site that's called drainage water management. And I provided here, there's a really nice video on this. So if you have this presentation, you can review this later. And if you want to click on that YouTube presentation, it will actually show you how these operate. But these are man-made structures on a field that you can alter throughout the season. So it gives you the opportunity then to either raise or lower the water table. And especially if you're working in areas that have seasonal extremes, if you have, a very wet season and a very dry season, which is often the case in many locations where they have very wet monsoonal type seasons during part of the year, and then very dry drought conditions in other parts of the year, other times of the year. You can actually then control your water table and can adjust it so that the water table is at a depth so that it's most in the right conditions for allowing the best crop management, so that the roots are at the water table. And so you're neither killing your crops by having too high a water table or excluding them from access to the water by having it too low. You can manage the water itself. And again, I recommend, if you are really interested in this, because I think this is a fascinating development that we utilize in many locations, to look at the YouTube presentation on that and gain more information from that, as well as you can go to the website that I mentioned at the bottom there and just see some examples of how this is used for water management. And so just kind of wrapping up some of the current priorities for our agency right now, outside of those conservation practices I mentioned, is currently we're looking at a number of priorities. One is advancing equity and justice and equal opportunity. We're looking at really trying to make sure that the practices, the financial and the technical assistance that we provide is done in an equitable fashion across the country, so that it's all people have access to the information and opportunities that we provide. There's many areas that have very poor farmers that might not even be aware of what we have to offer. And so we've been really pushing, trying to make sure that this information and the technical assistance and the financial opportunities are there for everybody to utilize. A main focus, and again, the office that I work with right now, is climate change. We have an Office of Climate Change, and we're looking at two aspects in climate change that relate to agriculture. And agriculture itself is a major aspect of our concerns with greenhouse gases and mitigation of CO2 and methane and nitrous oxide, trying to make sure that we mitigate some of those aspects. And then the other part of it is adaptation. And again, that's more my focus. How can we adapt our practices? How can we change what we do in the way of agriculture to manage and to stay viable in our agricultural production by adapting to the changes that are happening. Some areas are seeing increased seasonal rainfall. Some areas are seeing prolonged drought. Some areas are seeing changes in the average annual temperatures. The first frost and the when the temperatures are most adequate for doing the planting of the crops. These things are changing. The climate is changing, whether people wish to admit to that or not. Farmers, ranchers, foresters are seeing these changes. And so we can try to mitigate some of those changes, but we can also try to adapt to them as best we can. A third area that we're looking at is supporting urban agricultural, really working with folks, because a lot of agriculture now is occurring within smaller plots within urban conditions. So we're looking at, how can we as an agency be of more assistance to those that are part of the urban agricultural approach? What we call oftentimes hobby farms, 1 to 3 acres of land that people are growing different crops on. We're trying to then make sure that we are training and hiring a diverse workforce. And of course, we're still looking at how we build partnerships. No single agency in any country, no single agency can manage all the different aspects of what is necessary to support agriculture. So we're looking at working with other federal, state, local agencies and how we build partnerships to really provide the most opportunities and technical assistance that we can to those in the agricultural workforce. If you would like more information on our programs here, the website here is the NRCS website. And as it might apply to Azerbaijan, there's 2 areas that I would provide here that could be of assistance if you're looking for developing ways to utilize some of the technical and I don't know about the financial side of it, but certainly the technical side of support that we could provide in Azerbaijan or anywhere internationally. One is the U.S.D.A.'s Foreign Agricultural Service. Their website is here. And then within my agency, we have an international programs division, and the contact person, I left his name there. Of course, if you have other questions, please feel free to contact me and I'll be happy to assist where I can. But as with all the other programs that we've presented during these 4 different presentations, we are not always the experts when it comes to putting this information on the ground. We are providing an overview of these different parts of our different agencies that relate to water and water resources, but we know who to put you in contact with that could be the person on the ground that would help with those things. And so with that, I'll stop sharing my screen and I'll put on interpretation so I can try to answer any questions that there might be.
Thanks so much, Mike, for your excellent presentation. It's hard to believe that you only covered 12 of 88 different conservation approaches. That's absolutely incredible. I'm sure others feel the same in that there was a lot of information to absorb there, and I would go ahead and open the floor for any questions that folks might have for you. Again, feel free to ask your questions either in the chat or by raising your hand or unmuting. Anything is fine. While we wait for some potential questions to come in, Mike, you mentioned the NRCS website. Is that the best way for people to look into potentially some of those other water conservation approaches, the remaining ones of the 88?
Yes, that's probably the best approach. In fact, we just revamped our webpage just in the last few weeks, and so it's really refocused on folks from outside of our agency. So which is really kind of a nice design. So if you go in there and there's obviously, I think it's easy to map your way through our website. But if you just go under a search, and if you have an interest in, let's say, wetlands, just type in wetlands. You can type in conservation practices, any of those things that would potentially direct you to more information on that. And then at each of these sites, there's usually a link to contact an individual if you have specific questions and want to work one-on-one with somebody.
Great, thank you. That sounds very user-friendly, especially for a US government website. So hopefully people are able to check that out.
Hopefully, like I say, oftentimes when you're familiar with a program, an agency, and you might not see it from what an outsider's view is. So we're always open for input. If there's something that folks can't find, or if there's something that potentially is not clearly mapped out, then let us know, and then we can find ways to improve. Because again, sometimes we're familiar with it and not everybody is, and so we might take things for granted.
Absolutely. Just looking through the chat. I don't see any questions yet.
And feel free to contact me directly. I mean, if you don't want to ask questions over a video, I understand that too. Feel free. At the end of the presentation, my email address is there. I'd be happy to chat with any individuals that, and if I can, like I say, I might not be the right person to answer your question, but I can probably direct you to the person who can. So.
Thanks, Mike. And yes, hopefully our colleagues at the embassy will be able to share out the slides from today, which will include the email addresses. And I would also be happy to share a list of all of the email addresses for the speakers who participated in the series, so that you have them for an easy reference for any questions you might have for today's session or any of the previous sessions. I'm sure the previous experts would be more than happy to speak with any of you about questions you might have. Well, in the event that there aren't any burning questions, and that folks would potentially prefer to follow up later after they've had an opportunity to sort of absorb more of this information, I would like to say once again, thank you so much to our colleagues at the U.S. Embassy in Baku and our colleagues at the Ministry of Ecology and Natural Resources in Azerbaijan for all of their help putting this program together. It took place over many months, and we certainly would not have been able to do it without their kind help. I want to thank the experts, of course, for providing their expertise and for participating as part of this program, often very late into the evening for them here in the United States. Similarly, would like to thank the interpreter for participating as part of this program and ensuring that we are able to understand each other, recognizing that I certainly don't speak Azerbaijani, and I wouldn't necessarily expect someone to understand all of the technical terms we've heard today in English. And lastly, I would like to extend my appreciation to our Department of State DC colleagues who I believe had to drop off the line earlier today, but are nevertheless instrumental in ensuring that we can provide this technical assistance to our foreign government partners. One last opportunity, Mike, any of the other previous experts, would you like to say any final words?
I just want to say thank you for the opportunity to talk about two of the different programs that I work with. And it's, I won't speak for Don or Roman, but I have thoroughly enjoyed the opportunity both to talk about the work that we do, but also to learn more about Azerbaijan. In the process, we've been doing this for a little bit over a year now, and a lot of that time was spent learning what conditions are there and what issues are there. And I found it to be fascinating to have that aspect. For me, career growth, to learn a lot more about other areas and what your issues might be. So thank you very much for allowing us to do that.
Yes, this is Don Anderson. I'd like to echo those comments of Michael that I've really enjoyed the opportunity to learn a little bit more about some of the water issues and concerns in Azerbaijan. And I should add that I'd be eager to learn more. I'm hopeful that through these 4 different presentations we've done on 4 very different but related themes, it perhaps has hit upon some particular topics or themes or issues that are of particular interest to those who have sat in on the presentations. And I for one would be really interested in getting some feedback and hearing a little bit more from our counterparts in Azerbaijan about what in particular interests them and elements that they might want to learn more about or have more opportunity to discuss with some of their professional counterparts here in the United States.
Thank you, Dawn and Michael. This is Blake Doggart from the U.S. Embassy here in Baku. And just to follow, first, thank you so much for your expertise and everybody's expertise as part of this program. And I just wanted to follow on your comments, Dawn, to say that, I mean, we are open to trying to facilitate more of these types of events. But of course, we need to hear from our Azerbaijani colleagues, what is it that is most useful and interest to them. So I just open up the opportunity for them to talk to us and contact us about what they've found the most useful from this experience and how they see our technical support to, you know, how we can use technical support in the future and what would be the most useful. So again, thank you. Thank you, Elizabeth. And we are here to help.
Thanks so much, Blake. Yes, absolutely agreed. I think this is a conversation we will continue to have, obviously, well into the new year. I would strongly encourage our participants from today to reach out to our embassy colleagues with feedback, thoughts, suggestions for future areas of collaboration or areas that you would like to hear more about, because we recognize we can only say so much within, you know, an hour presentation, an hour overview, and there's so much more to learn on each of these topics. And in the meantime, I want to wish everyone a wonderful holiday season and look forward to hopefully speaking more with everyone in the new year. Thank you so much.